what we were commenting, what you commented, that really opened my mind talking about AI. You're just saying it's a silicon base, like, and we're carbon based. Like,
Yeah.
what would actually be the difference between us and a
And an
computer?
AI, right.
Once they get to a point of, like, Stephen Hawking, didn't he's like, in human, I don't know, life or
Yeah.
evolution, there's going to be a point, like, we should be worried about AI getting advanced enough where they're just like, they could pass the
Turing Test.
Turing test.
Yeah.
And I was listening to what's his name, Lex Friedman.
Lex Friedman, I love
Yeah,
him.
he's awesome. He
Yeah.
had like an, I don't know, a smart
Okay.
guy on,
Yeah.
and they were talking about, well, these things could either get to a point where they trick us into making us think that they
Yep.
could pass the Turing test, or they'll actually pass it. And I really do think, well,
What's the difference?
yeah. Then I'm reading Meditations by Marcus Aurelius right now, and a lot of, like, the Stoics believe that we have a part of us, like the universe. This could go into computers too.
Yeah.
That we have this, they call it logos, which is like logic. Well, we derive logic and logically, and
And then ethos, right?
ethos. I'm not as
Okay.
like, I learned about it in my ancient philosophy class, but not as well
Yeah.
knowledged in that. But the logos is just everything. It's like the God. I don't want to say God because that puts images in
Okay.
people's minds,
Right.
but it's just everything. And each one of us has a little bit of logos in us, which makes us human. Like, it's our fuel. Like, we have our meat vessels,
Yeah.
and we have our brain that's not us. Like, and then we have I think of it like a soul. Like, that's the fuel that powers us and makes us human. And I think animals have it too.
Yeah.
But I don't know because no one knows where consciousness come from, even though
Right.
I think they just pinpointed it. They saw some activation in a certain part of the brain, but no one really knows where it comes from. So do you think, like, a computer is going to be able, if they are conscious, will they be conscious like us, or just act consciously?
Well, I want to talk about us first.
Okay, yeah.
And where like you said, where our consciousness lies and what makes us human.
It's probably
right?
a good start.
Yeah, and it is the start. So, like, without getting into too many, like, religious beliefs and stuff, I'm gonna operate on what we know today, or at least what I know today, and assume that we did evolve from a smaller, simpler organism.
Yeah.
One of my favorite like quotes or whatever is actually from the head of artificial intelligence at Tesla, Andrej Karpathy, and he said, if you shine photons at a rock for long enough, eventually a Tesla will appear. A Tesla car, like literally like a Model S. And he's like, what the hell is this guy talking about? And it's like, if you believe, like, the traditional scientific path of evolution, right? Earth at one point, was, and it still is, just a giant rock. And the sun is what gives all energy of any kind to our planet. And, billions and trillions of years ago, right? It was literally just a floating rock. And after enough time of the sun shining on it, right, these photons from the sun allowed maybe a single cell organism to be formed, which grew into multi-cell organisms, bacteria, developed feet and whatever, lungs, got out of the water. Maybe thousands of years later, humans were just stumbling around eating grass and stuff, and then one guy picked up a rock and threw it, and that was the very first, use of a tool. And we've just grown from there, right? So literally, if you shine photons, like, from the sun long enough at the earth, you get what we have today, which is like Teslas and businesses and internet. It's crazy, right? But, like, think about from, like, a consciousness development standpoint, it all did come from somewhere. And I mean, this then gets to, like, what do you believe, So certain people have totally different beliefs on this, and that's totally fine. Like, I probably have a pretty boring or, like, maybe pessimistic view, which is, like, if you could perfectly simulate so we live in, like, a quantum universe where things don't exist in a binary state. So computers right now are binary, ones and zeros.
Just on and off.
Yeah. Our universe, and, like, specifically, like, the position of electrons is something that's not certain. We don't know exactly where an electron is in a given orbital level at any time. We can only approximate it. And I think that's why, if you were to like simulate the human brain and you tried to build this perfect simulation, it wouldn't produce, like James Cunningham, because there is the unknown in our ability to simulate it. Like, we don't understand exactly where all these electrons are and exactly how they interact. And that, I think, is where a lot of our consciousness and our soul and personality come from. I am a believer that if you had, a perfect quantum computer simulation of any given organism, and you could accelerate that simulation to be faster than the rate of occurrence, like the rate of at which time passes, you'd eventually develop like a human being. And, that might take some of the randomness and personality, like fun stuff, out of being human. But at the end of the day, at least, the way I've interpreted what we know today is we are just electrons firing between neurons, and we don't quite understand how it all works today. But in computers, it's the exact same thing. The difference being we built, those logic gates to process information. We didn't build everything in our brains. They came from somewhere, wherever you want to believe. So if we continue to evolve and develop silicon-based thought processors, we'll call them, not computers, or information processors, because that's all we are. Eventually, we might stumble across something that either resembles or even exceeds the information processing capabilities of ourselves. And I think the biggest difference will be scale, because we're limited by, our carbon-based life forms. We need
food.
Yeah, we need food. We need sleep, water, and we can't process as much information as computers can. So eventually, if we do get to a point where we can build a system or an intelligence that can, really pass the Turing Test, which is, for, if anyone doesn't know, it's just like a simple test that says a system or a computer is deemed to have passed the Turing Test if it can convince a human that it's indistinguishable from a human or a computer. So if you go online and you have a conversation with a chat bot, honestly, some of them, if it's just a text conversation, it would probably pass the Turing Test. But now people argue well, that's not enough, because if you take away the visual aspect or whatever, maybe it's not fair. Regardless, if a computer really does get to the point where it's indistinguishable from a human, it's indistinguishable from a human. And I don't think there's that big of a difference, other than, like I said, the scale and the origins.
Yeah. I also feel like for humans, I don't know if computer silicone-based forms are ever going to get to the point where they can, because our bodies are constructed so we can, like you were saying earlier, perceive the world. Like, we could touch, we could taste, we can smell, we could see, we could feel, which I think is a big part. We have emotions.
Yeah.
And I don't know if emotions come from an evolution of our brains so we can get better at surviving, because we're social animals.
Yeah.
Because we see it in primates too, that they have morals, they have empathy. They have, by a bunch of examples, one of them, what's it called? Chimp gets in a fight with another chimp. The chimp that loses, a baby chimp, will go up to it and console it.
Yeah.
It shows morals.
Emotion.
And there's and we see that we even see that in trees. Trees speak underground, and they're connected. This is nuts to me. This is why, another thing I didn't say in the food. Well, if we believe in ethical reasons for not killing animals, well, we're doing the same with plants, because they're alive too and they communicate with each other. But whatever. Back to these trees, they communicate underground, and older trees that have a lot of energy or whatever, they give it to the younger trees so they can grow.
Right.
And if one has more and another doesn't have a lot one day, then they'll give it to them and they'll share. And the bats do it too. If one bat eats a lot and one doesn't, they'll give them food, because next time maybe they'll give them some. So we see it everywhere, and I'm not sure if it makes sense from an evolutionary standpoint, because if we're all going to, we want each other to survive, because if you survive, I'm better off from it. So it makes sense from that way. And I don't know if silicon based will evolve in
Yeah.
that way.
I think, like, to bring it a bit more back to earth, the way AI is being developed currently, like my comment on YouTube said, current AI is just tricking rocks into thinking. And that's exactly what it is. Like, the way that we develop AI on like a really quick tutorial scale is we kind of looked at the brain and said, like, all right, we have a ton of these neurons. When like a signal passes to this one, it will only pass maybe like a quarter of that amount of electricity onto the next one, or like 70% or 30%. It has like these weights set to it on like how much it passes to the next one, and that continues through all the different neurons in our brain. And that's basically what like computer scientists of the early 2000s or even like the 90s looked at and said, you know what, let's try to do this in computers where we have these weights that we set. So like the way we train AIs nowadays is you have this neural network is what it's called, of a ton of like abstract weights. They're just like made up things, right? We just have it. All it is like on the simplest level, if I pass into an algorithm a 1, like the number 1, it goes through a weight and then it passes out like 0.7 or whatever. That's like a single neuron. And like if I combine that, go to the next one maybe passes 50%. So if I pass it in 0.7, pass out 0.35. And we basically, as like computer scientists, just put a ton of these weights together in like a neural network, like a bunch of them, and started them all off at whatever, like random numbers. We gave them totally random weights. And then we took something like an image of a water bottle, and we were say you're trying to build like an algorithm that can tell whether something's an object or like a food, right? We pass it in this water bottle image, and you take the image and you convert it into numbers, which is literally just like, if I take an image on my phone, it has a resolution like 1920 by 1080 or something like that. Every one of those pixels has like 3 values, red, green, blue, and sometimes alpha. Anyway, so like pictures are just numbers. That's all I'm saying.
Okay.
So we convert the picture to a ton of numbers, and then to this neural network, we pass in all these numbers, and it goes through the weights totally randomly and like spits out a random 1 or 0 at the end. Like we make them converge on something that if it's above 0.5, it'll produce a 1. If it's less than 0.5, it'll produce a 0. And that tells us like, yes, we think this is an object, or no, we think it's food, or either way, you know. That's like training an AI. And at first it's like totally random and it produces a terrible error. But if I give it millions of pictures of water bottles and food, eventually it keeps slowly adjusting those weights. Because like I show it the correct answer after I say, okay, you got that one wrong. Like this is not food. And then it goes back and it says, well, maybe if I adjusted these couple weights a little bit in this direction, we'll be closer to the right answer. And we do that millions and millions of times. That's how these neural networks actually learn. And that's the technology that's driving self-driving cars, the thing that gives you your YouTube recommendeds. It's just much bigger neural networks that take in tons of data. So that's like, things like that are called like narrow AI, where it's focused on one or maybe a few tasks. The scary thing people think of is like general AI, where, I mean, you scale it up, the inputs to that neural network is all the data in the universe, and the output is, you know, unknown. It could do whatever it wants. That's kind of like general AI, which doesn't exist as far as we know today. So I think the scarier short-term reality is several very good narrow-based AI products.
Narrow AI products kind of seem like babies.
Yeah.
And us. Just we learn. Like
Yeah.
we put things in our mouth as a kid and we're like,
Yeah.
not
That's
food.
Exactly. Yeah.
Yeah.
They just learn. Well, I actually learn a lot slower, but it's that they can take 1 billion tests in like
quickly.
a minute. Yeah.
So
Yeah.
do you think if these general AI comes to be, or even the narrow AI, you think it's immoral that we're thinking, because have you seen, do you watch Black Mirror?
Yeah, I know what you're going with.
Yeah.
Yeah.
The guy, is it immoral that we're causing, because there's Descartes who says, I think, therefore I am.
Right.
So if a computer thinks it's thinking,
Yep. Then
should we even be using it?
And does it deserve rights?
Exactly.
Yeah. Yeah, man. I mean,
computer scientists need to be thinking about this stuff, because they could be creating.
Right.
life?
I think for the time being, we're nowhere near a decision like that. But you're right in that, things can move quickly and we should be thinking about it. If it's something that's still dependent on human like interaction where like it needs an operator or it needs input, then, I think it's justified to call it a tool. When it gets to the point where it no longer requires our maintenance or our support, then I honestly don't think it will be our decision whether or not we use it.
Yeah.
It'll be its decision whether it
Fuck.
uses us.